Lesson 6 is on irrational numbers, and an irrational number is a number that when it is turned into a decimal does not repeat itself ever and never stops. So, for instance, if you type pi into a calculator, pi is a number that is an irrational number. It continues on and on and on. Also, square roots of numbers that are not perfect squares, for instance, 4 is a perfect square, and the square root of 4 is 2. But 2 is not a perfect square. The square root of 2 goes on and on and on and on. It's going to be 1.41, and it's going to keep going. And it's not going to repeat itself like the fraction 1/3, which goes 0.333. That never ends, but it also is just 3 repeating. So irrational numbers are numbers that repeat, or that do not end and do not repeat. So that said, let's dive into the assignment. Bonnie drove 108 miles in 2 hours. What was her average speed? Well, when we talk about speed we give in miles per hour. So we're going to take the miles she drove, 108 miles, and divide it by the hours, 2 hours. So 108 divided by 2, well, 100 divided by 2 would be 50, and 8 divided by 2 would be 4. So she must have averaged 54 miles per hour. Before the gift was revealed, only 2/7 of the crowd guessed correctly. If there were 294 people in the crowd, how many guessed correctly before it was revealed? So 2/7 of 294 people means we're going to take 294 and multiply. The word of in math means multiply. And when we multiply by a fraction, what we do is we multiply by the numerator and divide by the denominator. So what this looks like in a calculation form is 294 times 2 divided by 7. So over here we can do some calculations. 294 times 2. 2 times 4 is 8. 2 times 9 is 18. And then 2 times 2 is 4, plus that 1 is 5. So we have 588 divided by 7. And then 588 divided by 7. 7 can't go into 5, but it can go into 58 8 times. 8 times 7 is 56. 58 minus 56 is 2. Bring the 8 down. 7 goes into 28 4 times. 4 times 7 is 28. 28 minus 28 is 0. So we're done. So 588 divided by 7 is 84 people guessed correctly. Says for problems 3 and 4, identify the plot, write an equation, and solve the problem. So, plot, equation, solution. Roger completed 28 of 41 math exercises during school. How many exercises are left to complete after school? So we started with 41, we've done 28, and we want to know how many are left. The plot for that is a separating problem. And the equation for separating is what you started with, so in this case 41, minus what went away, in this case the problems that he's already done, 28, and that gives you what's left. I always do L's in cursive so they don't get confused with 1s. So the solution then, 41 minus 28 is 13 problems are left. And we could check that. 13 plus 28, well, 28 plus 3 is 31. 31 plus 10 is 41. So that accounts for all of the math problems. All right, same thing in number 4. In Major League Baseball in 1960, there were 2 leagues of 8 teams each. By 1998, the total number of teams had expanded to 30. How many teams were added from 1960 to 1998? This one actually has 2 parts to it. We have equal groups to figure out how many total teams are in the Major League Baseball in 1960. So first is equal groups plot. And the equation for that is the number of groups, which is 2 leagues, times the number in each group, which is 8 teams, equals the total. And then the solution for that, 2 times 8 is 16 teams in 1960. Okay? The second part to this problem is to figure out how many more teams. And when they say more teams or you're comparing, that is a comparing problem. So the second part of this is the plot is comparing. And when we take a comparing problem, the equation is the bigger number, the greater number, which is 30, minus the lesser number, which we already calculated now is 16, and that equals the difference, D. So then the solution, 30 minus 16, is 14. So there were 14 more teams added between 1960 and 1998. In number 5, we have the cubed root of 64, and what that says is what number times itself 3 times equals the number underneath the what's called a radical, or the root sign. So looking at this, since it's an even number, I know that the number itself is going to be even. So I might start with 2 and see what that is. Well, 2 times 2 is 4, times 2 is 8, so that's not enough. So then I'd probably try 4. 4 times 4 is 16, and then 16 times 4 is 6 times 4 is 24. 4 times 1 is 4, plus 2 is 64. So 4 times itself 3 times is 64. So the cubed root of 64 is 4. In number 6, we have 10 to the 3rd power, and what that means is 10 times itself 3 times. And when we multiply by 10, we just count the zeros. So 1 times 1 times 1 is 1, and then 1, 2, 3 zeros after it. The other shortcut is that you might notice now that we've written it is that the exponent is actually how many zeros there are. So it's when it's 10 to a power, you write 1 and then the exponent number of zeros after it. Numbers 7 and 8 deal with fractions and adding and subtracting them. So when we're adding and subtracting fractions, we need to have a common denominator. So looking at these 2 denominators, I can see that 7 I could turn into a 14 pretty easily by multiplying by 2. So I would do 6 over 7, and then I would put it over something over 14. So I'm going to multiply 7 by 2 to get to 14. Whatever I do on the bottom, I need to do on the top. 6 times 2 is 12. So I have 12 fourteenths. So if I rewrite the problem, 6 sevenths I'm going to replace with 12 fourteenths. And then plus 1 14th stays the same. When I add fractions, I add the top, the numerator. So 12 plus 1 is 13. And I keep the denominator the same once I have that common denominator. So 13 fourteenths is the final answer for number 7. In number 8, we have to first turn the mixed numbers into improper fractions, which means higher numerators than denominators. So when I have the number 2, what that means in terms of eighths is I have 8 eighths is 1, and another 8 eighths is 2. So this is the 2. And then I also have 5 eighths from that on top of it. So how many total eighths I have is 8 plus 8 plus 5. 8 plus 8 is 16 plus 5 is 21. So I have 21 eighths. I can rewrite 2 and 5 eighths as 21 eighths. And then for 1 and 1/4, 1 is 4 fourths. And then plus that 1/4 is 5 fourths. So I can replace 1 and 1/4 with 5 fourths. So if I rewrite that problem with those numbers that I just did, I would have 21 eighths minus 5 fourths. But I still have a problem because I don't have a common denominator. 8 and 4 are not the same, so I can't do the subtraction yet. But looking at this, I can see, well, if I just multiply this 4 by 2, I would end up with an 8. So I'm going to turn 5 fourths into something over 8. And to do that, I multiply by 2 to get 4 times 2 is 8. Whatever I do to the bottom, I have to do to the top. 5 times 2 is 10. So now my problem becomes 21 over 8 minus 10 over 8. And then just like in adding fractions with the same denominator, you subtract, in this case, the numerators. So 21 minus 10 is 11. And then the denominators stay the same, 8. And then the last step is to write it as a proper fraction again. Right now we have a bigger number on top than on the bottom. So we're going to take out a full 1. So I could say 11 is the same thing as 8 plus 3. So I have 8 eighths, which is 1, and 3 eighths left over. So I have 1 and 3 eighths. And that is my final answer. Number 9 says find the perimeter and area of this figure. Well, we know that this side right here is 3 meters, because 3 meters plus 4 meters equals 7 meters total. And we know that this side over here is 6 meters, because 4 meters and 2 meters equals 6 meters. So now to find the perimeter, we just add up all the sides. So we have 2 plus 7 plus 6 plus 4 plus 4 plus 3 plus, and that's it. So 1, 2, 3, 4, 5, 6 sides. 1, 2, 3, 4, 5, 6 sides. 2 and 7 is 9, and 6 is 15. 4 is 19, 4 is 23, and 3 is 26. And the units on perimeter are the same as the units as the length that they give us. For area, we're going to need to cut it into 2 rectangles. So I'm going to make the division there. And I'm going to say that the area of this is going to be 2 times 3, which is 6. And the area of this is going to be 4 times 6, which is 24. So the area is going to be the 2 of those things added together. So 6 plus 24 is 30. And the units on area are the units on the length squared. In number 10, we want to express with exponents. So we go through and we find repeats of the same number or variable being multiplied together. So I see 2 x's. I only see 1 4, so I'm going to say 4, and then 2 x's means x squared, because they're being multiplied. X times x is x squared. And then I see 2 y's, so y squared, and then I only see 1 z. In B, I see 1 3, and then 2 a's, so a squared, 3 b's, so b cubed, and then 1 c. In 11, it says compare. We have the square root of 16 and 7. Well, the square root of 16 asks the question, what number times itself is 16? So again, I know that the number has to be even since the number underneath is even here. 16, so I'll start with 2. Well, 2 times 2 is 4, so that's not high enough. So next I'll try 4. 4 times 4 is 16, so the square root of 16 is 4. So now we're comparing 4 and 7. Well, clearly 7 is bigger. So 7 is bigger than the square root of 16. Then we have the square root of 81, which asks the question, what number times itself gives us gives us 81? It almost gave you the answer there. It's odd, so I know that it's going to be an odd number. So I could start with 3. 3 times 3 is 9. Well, that didn't work. Then I could try 5. 5 times 5 is 25. So that wasn't high enough. I could try 7. 7 times 7 is 49. I'm getting closer. And then I could try 9. 9 times 9 is 81. So the square root of 81 is 9. And then on this side we have 3 squared. Well, 3 times 3 is 9. So the square root of 81 is equal to 3 squared because they both equal 9. Solve the problems 12 through 15 by inspection. So that means we're going to look at the problem, we're going to think about what number would work in place of the variable, the letter, and then we're going to check our answer in the end. So in number 12, we have 4z minus 2 equals 30. So this number here needs to be 32, because 32 minus 2 would give 30. So now our question is, what number times 4 gives us 32? And that is 8. So now we're going to check, and we're going to say 4 times 8 minus 2. 4 times 8 is 32, minus 2 is 30. So that one checks out. The next one, we have 200 minus a number equals 140. So what number, when I subtract it off of 200, would give me 140? Well, I think it would be 60. So let's say A is 60, and then let's give it a try. So we will do 200 minus 60. If I do it below here, just to double check, 0 minus 0 is 0, and 20 minus 6 is 14. So 140. So that checks out. $50 is equal to 5 times a number plus 10. So what number plus 10 would give me 50 is 40. So this number here must equal 40. 5 times a number has to be 40, then 40 plus 10 would be 50. Well, the number that 5 times something equals 40, 5 times 8 equals 40. So let's try 8. So that would say that we have 5 times 8 plus 10, and that would be 40 plus 10 equals 50, which is what we're going for. And then the last of these problems, we have 7 equals x divided by 3. So what number, when I divide it by 3, gives me 7? Well, if I count by 3 7 times, 3, 6, 9, 12, 15, 18, 21, I get 21. So I'm going to guess that x is 21. And then I'm going to check it. 21 divided by 3, 3, 6, 9, 12, gives me 7. So that works. Compute 75% of 800. There's a couple different ways to do this. The first way would be to do it straight percent-wise. It's not necessarily the easiest, but I could treat it as percents. And I would look at 75% is 7 10%, and half of a 10%. So 10% of 800 if the decimal point is not there, it's way at the end. 10%, I take that decimal point and I move it one place to the left. So 10% of 800 is 80. I need 7 of those to get to 70%. So 7 times 80 is 560. And then I need half of 80 on top of that to get the 5%. So half of 80 is 40. $560 and 40 is 600. So it looks like 75% of 800 is 600. Now, a little bit easier way to do that is to recognize that 75% is the same thing as the fraction 3/4. So you could also do it where you say, all right, 3/4 times 800. That means 3 times 800, and then divided by 4. 3 times 800, 3 times 8 is 24. And then we put the zeros on, and then divided by 4. Well, 24 divided by 4 is 6, and then we put the zeros back on. Both ways give you 600, so we must have done something right. It's nice to have multiple ways to do a problem because then you can check your answer. Find AC when A is 3 and C is 39. So 4 times A is 3 and C is 39. 4 times 3 is 12. So I'm going to say that 12 times 40 would be and then I have to subtract a 12 off of that. Because 40 minus 1 is 39. So 12 times 40 would be 480. And then minus 12. 480 minus 12 would be, let's see, 468. Rearrange the factors to make the calculation easier. Well, it would be really easy if I multiplied the 8 times 25. If you think about it, 8 quarters is $2, so we'd have 200 when we multiply 8 by 25. So the first thing that I want to do is take and move and switch places of the 49 and the 25. So 8 times 25 times 49. Justifying my step, I can do that because of the commutative property, which says that the order that I multiply things in, commutative, the order I multiply things in or add things in does not matter as long as it's only multiplying or only adding. And then I would like to be able to do the 8 times 25 first, so I'm going to switch where the parentheses are. And I can do that by the associative property, which says that the groupings, or where the parentheses are, don't matter when you're just multiplying or just adding. So then 8 times 25 is 200. And then 2 times 49, well, it's going to be 2 less than 100, because I have 49 times 49, so 98. And then I'll have 2 zeros at the end. Momentum is the product of mass and velocity. P, which stands for momentum, is equal to m, mass, times v, velocity. Find P when m equals 40 and v equals 11. So P equals m, 40, times v, 11. Well, 40 times 11, 4 times 11 would be 44, and then I stick the 0 back on in the end. What is the mean and the median of 2, 4, 6, and 8? Well, the mean would be add them up and divide by how many there are. So 2 plus 4 plus 6 plus 8. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. And then there are 4 numbers, so I divide by 4. So 5 is the mean. The median, I put it in order from smallest to biggest. So 2, 4, 6, 8, and I count into the middle. So when I have 2 in the middle, I find the average of those to find the middle number. So 4 plus 6 is 10, and then there's 2 numbers. 10 divided by 2 is 5. So the mean and the median are both 5. Write the prime factorization of 400. Use exponents for repeated factors. So for prime factorization, I'm going to start off with 400. Two numbers that multiply to give me 400. 20 and 20 would. 2 times 2 would give me the 4, and then I have 2 zeros. And then two numbers that multiply to give me 20 are 4 and 5, and 4 and 5. 5 is a prime number, but 4 isn't. So two numbers that multiply to give me 4 are 2 and 2. And two numbers that multiply to give me 4 are 2 and 2. And 5 is just carry down since they're already prime. So the prime factorization of 400 is 2 times 2 times 5 times 2 times 2 times 5. 2 times 2 is 4 times 5 is 20. 2 times 2 is 4 times 5 is 20. 20 times 20 is 40. Now they want us to use exponents for repeated factors. So I have 1, 2, 3, 4 2's. So I would say 2 to the 4th. And then times, I have 1, 2, 5's. So 5 squared. 2 to the 4th times 5 squared equals 500, or 400. All right, number 22. What is the product of the sum? So we're going to be multiplying two things. And the first thing that we're going to multiply by is the sum of 10 and 5. And then the second thing, the second factor, is the difference of 10 and 5. So 10 plus 5 is 15, and then 10 minus 5 is 5. 15 times 5 is, well, 5 times 10 would be 50, and 5 times 5 is 25. 25 and 50 is 75. Express 1/8 as a decimal and a percent. Well, when I want to figure out what a fraction is as a decimal, one way to do it that will always work is to take the numerator and divide it by the denominator. So if I take 1 divided by 8, 8 can't go into 1, so what I do is I add a decimal point. The number 1.0 is the same as the number 1. When I put the decimal point, I also put one up above. So now the question becomes, how many times does 8 go into 10? Well, it goes into 10 once. 1 times 8 is 8. And then 10 minus 8 is 2. Since I have a remainder, what I'm going to do is add another 0. 1.00 is still just 1. I'm going to bring that 0 down. And now how many times does 8 go into 20? It goes into 22 times. 2 times 8 is 16. 20 minus 16 is 4. Since I still have a remainder, I'm going to add another 0. 1.000 is still just 1. I haven't changed the number yet. I'm going to bring that 0 down, just like I brought that down. And now the question is, how many times does 8 go into 40? It goes into 40 5 times. 5 times 8 is 40. And 40 minus 40 is 0. When I end up with 0, I know I'm done. So 1/8 as a decimal is 0.125. And then to figure out a percent, we take that decimal point and we move it 2 places to the right. So 1, 2. So as a percent, it's going to be 12.5%. Another way that you could have looked at that is said that, well, 1/8 is half of 1/4, and 1/4 is 25%. So 25% divided by 2 gives me 12.5%. The relationship between rate, r, and time, t, and distance, d, is expressed in the formula d equals rt. Find d when r equals 55 miles per hour and t equals 2 hours. So d equals rate, 55 times time, 2. Well, 55 times 2, 5 times 2 would be 10, and 5 times 2 would be 10, so 110, and distance in miles, since they were miles per hour. Number 25 says list the even prime numbers. Now remember, a prime number is a number that when you divide it, or the only factors for it are 1 and itself. So any number that's even will have 2 as a factor. So the only even prime number that you can have is 2, because then it's divisible by 2, which is itself, and 1. But if I went up to 4 or 6 or 8, when I can divide it by 2, it's no longer prime. So the only even prime number is 2. All right, simplify. And when they say simplify on here, folks, I want to make sure that we're not just reaching for the calculator, because these are things that they expect that you could do in your head. You'll notice throughout the homework, I don't typically reach for a calculator, and it's because I want to show you how you would get the answers without. So we have 123 minus 321. What I would do in this case is I would recognize, all right, this number is smaller than this number, so my answer will be negative. And it's going to be a lot easier if I do it the reverse subtraction. So I'm going to do 321 minus 123. And then I will borrow. So 11 minus 3 is 8. Borrow again. 11 minus 2 is 9. And then 2 minus 1 is 1. Now, since I did it the opposite direction, this is actually a negative number. So this is equal to negative 198, since the other direction was equal to positive 198. 2001 hours divided by 3. Well, 2001 divided by 3. How many times does 3 go into 2? It doesn't. So I move on. How many times does 3 go into 20? It can go in 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring the 0 down. I have 20 again, which I already figured out. I can put in 6 times. Whoa, buddy. Let's try this a little bit lower this time, so I can actually write. So we have 2001 divided by 3. So far we have 6 and 6, 18, 20. All right, 6 times 6 is 18. So I have 21. 3 goes into 21 7 times. 7 times 3 is 21. Since I end up with 0, I'm done. So 2001 hours divided by 3 hours is 667 hours. For problems 28 through 30, choose from this list all correct answers. So let's make sure we know what each of these are. We have integers, which include both positive and negative and 0 whole numbers. Whole numbers, which include all numbers and 0. And then these are positive whole numbers and 0. Natural numbers is another word for counting numbers. So that's only positive whole numbers, not even 0. Rational numbers include fractions, decimals that end or repeat. Irrational numbers include the numbers that are decimals that do not end, do not repeat, and real numbers includes all numbers. So rational, irrational, integers, whole numbers, natural numbers, etc. So if we choose one of the letters A through E, we also will be choosing F in problems 28 through 30. So the number -2 is a member of which set or sets of numbers? Well, since it's negative, it rules out being a whole or a natural number. So it's an integer because it's negative. It is a rational number since it ends. It's a decimal that ends. It's just 2, so that's D. And then, like I said, if we're choosing any of the other ones, it also is going to be F. The number square root of 2 is a member of which sets or sets of numbers? Well, 2 is not a perfect square, so if I take the square root of it, it's not going to be a pretty number, as I say. So it's going to be an irrational number, a number that does not repeat and does not end as a decimal. So square root of 2 is an irrational number, and it's also a real number, since real numbers are all the numbers to choose from. And then the last one, the number 1/2, is a member of which set or sets of numbers. So it can't be an integer, it can't be a whole number, it can't be a natural number, because those are only the whole numbers, not fractions and decimals. But 1/2 does terminate as a decimal. So as a decimal, it's 0.5. It doesn't go on forever. It terminates, so it's a rational number, D, and then it would also be a real number.